Welcome to the SOLIDWORKS Motion Studies webcast. This webcast covers simulations of motion for assemblies. My name is Bill Mitchell. I'll be doing the presentation for this topic today. So the first thing that we're going to cover as far as motion studies and animations are concerned within SOLIDWORKS are the different types of motion studies that you can create. The first type is a simple animation. This functionality is available in core SOLIDWORKS. In addition to the basic animations, and I'll describe kind of what differentiates each type in a moment, but you can also do basic motion studies in core SOLIDWORKS. In addition to those two types of studies, you can do motion analysis. This requires SOLIDWORKS Motion, which is available in any of the simulation products or SOLIDWORKS Premium. Event-based motion analysis is new for SOLIDWORKS 2010, and that is available in SOLIDWORKS Simulation Professional. Keep in mind that both SOLIDWORKS Motion and simulation products are add-ins, so this requires SOLIDWORKS in addition to those items. Another thing to cover are the different types of solvers that are used, and I guess understanding what the solver is capable of helps you create the appropriate type of animation. One benefit of using the appropriate solver is that it will solve more quickly, and depending on the level of accuracy and what your goals are for the animation, you may not need to invest the time to do a complete motion analysis when all you really want to do is to animate the part for a presentation, those types of things where you want to save out an AVI file to show a customer or for a presentation at work. So the different types of solvers that are available within animation, for the basic animation is the 3D CM from D Cubed. This is good for simple animations which use interpolation between changing dimension values, rotating the camera around the part, and I've got an example of that to show in a moment. Another type is a basic motion. This uses the physics solver from NVIDIA, and this is more of a physics solver that is commonly used in video games, and it'll approximate the effects of motors, springs, collisions, and gravity, and it takes mass into calculation for its results. This is appropriate for animations that require physics-based simulation, things like gravity, but you don't necessarily need to get any sort of analytic information from the animation. It's just showing how the assembly works in real life or as close to it as you can simulate within the animation. The third type of solver is the Addins solver from MSC Software. This analyzes forces, torques, power consumption, and so on, and allows you to plot resultant kinematic quantities over time, and you can have charts and those types of things on your animation, and then also use that in conjunction with the SOLIDWORKS simulation add-in so that you can specify specific time frames or keyframes for the simulation add-in to go in and do an analysis while the part is animating. So those are the different types of studies that are available, and again, understanding which one is appropriate for your goal will save you time, processor time, if nothing else. So go ahead and talk about the first thing that is kind of optional as far as the animations go. You can create cameras, and they can be used to view the animation kind of from predefined points of view. You can change a number of different aspects of the camera, field of view, camera roll, target a specific point on the model. You can also use depth of field, which is only going to be used visible rather in the rendered animation, and that does require the PhotoWorks add-in, so that would be available in SOLIDWORKS Professional or better, SOLIDWORKS Professional or Premium. So camera-based animations effectively are what you're going to be doing is you're going to create key points to animate the camera properties as it rotates around the model. You can create a sketch entity and then attach the camera to that entity to have it create a motion path to kind of do a flyby type of animation. So we'll go ahead and take a look at that within SOLIDWORKS. I've got an example here, and this is one of the SOLIDWORKS demonstration files. This is a radial arm saw, and you can see that within the camera you've got a camera path, and this is a 3D sketch. Let me zoom out just a little bit so you can see that this sketch kind of runs all the way around the part or around the assembly. They also have created a sketch called camera target, and that is effectively just making an entity for the camera to focus on as it goes through the path. Whenever you create a camera, it will appear within your lights and cameras. You can see the camera at that point. It'll also be available if you tap your space bar you should see a camera at the bottom of the list. So you can view the part through that particular camera setting. So if you've got perspective and those types of things, you can kind of see what the animation or what that point of view would look like from the camera's point of view. Going over to the animation tab, so coming down to the bottom, you can see that within this particular assembly, the animation is reasonably simple. It's just using the animation solver, and then they've created a camera. If I right click on this and go to the camera properties, and actually this would be a little bit easier to display from this side, so we can see the entire tree or entire settings. They've got the camera aimed at a particular target, and the target is the line, which is in this segment of the assembly. And then lock camera position except when editing, so now that camera will not be able to be modified or adjusted inadvertently. You'll have to purposely come in to this dialog box. And then the camera position by selection is checked, and then they're using that spline at camera path. So now and then there's also some other settings. Perspective is turned on, so that changes the vanishing point of the model, and that's going to be up to your personal decision as far as how that looks. But the key things as far as this camera goes, and using the camera sled effect is what it's called, is going to be aimed at the target, and then it's going to be targeted at a particular line, and then it's attached to a spline. So let's take a look at what effect that has. Coming back into our animation tree, you can see that the camera itself at different key points arrives or is being repositioned along that spline at different key points within the time frame. And this is about a 25-second animation. So we'll go ahead and play this from the start, and you can see that it flies through that spline or moves along that 3D sketch. And again, this is a completely optional step. You don't necessarily have to go through the trouble of creating a camera sled. You can also reposition the assembly dynamically. A camera sled is nice for flybys, is really what that amounts to. The second aspect of this animation is that they're changing particular mate properties during the course of the animation. So putting my mouse cursor over each one of the keyframes that have already been created, you can see that this particular, it starts at 90 degrees, it changes to 45 degrees, changes to 135 degrees, and then back to 90 degrees. So this is effectively moving the head, or rotating the head rather, the table back and forth. Now if you want to zoom in tighter, you've got some zoom controls over in the bottom right, and that allows you to get a little bit finer control over the timing, or you can zoom to fit to where the entire animation fits within the window. So that's kind of the basic animation, and I'll go through and create a little bit of a simpler example that doesn't have so many components in a moment. Another aspect to the animations, however, or things that you might want to consider while you're setting up your animations, are the use of lights. You can create multiple lights within an animation. There's three different types of lights that you can create within SOLIDWORKS. A directional light, which is the source is infinitely far away from the model, and it creates a columned light source with parallel rays, and then you can modify the intensity, color, and position of that light. The second type of light is a spotlight. This is a restricted focused light with a conical shape, and it's brightest at its center, and it can be aimed at a specific area of the model. You can also modify its intensity, color, position, and then on this particular instance, the beam angle. And then the third type of light that you can create is a point light. And this is a very small light source located at a specific coordinate within the model space, and then emits lights in all directions, and again you can modify its intensity, color, and position. So to go through and create the lights within SOLIDWORKS, you would go to your lights folder within the feature tree, right click, and then you can add the different types of lights depending on what your desire is. Going back into the animation, you can also add lights. At this point you can show the lights if you right click, and then you can, at different keyframes, turn the lights on and off if you wanted to change the lighting on the model during the course of the animation for some reason. So let's take a look at making a animation from the beginning. But actually, before we do that, if you wanted to publish this, let's talk a little bit about the publishing of an animation. You've got save animation. Whenever you save it, you've got basically you can create a series of bitmaps or TGA files, or in most cases people will want to save an AVI file. You can change the aspect ratio, adjust the frames per second, and then notice that there's only one renderer available. If I come back over to my list of SOLIDWORKS add-ins and I turn on PhotoWorks, so now that enables the PhotoWorks add-in. For the finish loading. You can see now at this point I've got the PhotoWorks buffer. So what that'll do is use the PhotoWorks settings, textures, lighting, those types of things that are specific to PhotoWorks. So as it's creating the animation, it'll use those settings. Otherwise, if you in SOLIDWORKS screen, a lot of times that would be more than sufficient, especially with real view. It would give you a suitable result. So in any event, this is that's how you would export any given animation. You can also schedule that to be published at a later time so that you're not using your system resources during working hours. A lot of times you might want to publish an animation after hours so that you can continue working, because publishing an animation can be fairly demanding on the system. If you've got a 64-bit system with a lot of cores and a lot of RAM, then obviously that time would be greatly reduced. But in any event, you can schedule it later on if you so desire. So let's go ahead and take a look at creating a new animation from a little bit of more simple assembly. So this is a very simple assembly file that I created just to kind of illustrate how things get created. Before we get too far into that, switch back to PowerPoint and cover a little bit about the basic things about animation that you should probably understand before you start creating one. First, you can use mates to restrict motion of components in an assembly, and then you can also add motors to drive the motion of one or more parts of a given assembly. You can prescribe the position of components at various times using key points, which are the little diamonds that you will see in the timeline. And then on a per key point basis, you can define the interpolation to define how it transitions in and out of those key points. And then another consideration, again, is as you're creating the animation, is what solver do you want? The solver is adjusted in the pull-down menu, which we'll see in just a moment. So let's go ahead and go back to SOLIDWORKS, and we'll create a new motion study from scratch. And just to simplify processing time, I'm going to turn PhotoWorks off. So one of the first things that you can do within a given animation is use the animation wizard. If something is simply you just want to rotate the model, or within an assembly file, say you've got a configuration with exploded views, so I'm going to create a new exploded view, and maybe select that component. Something to that effect. Going back into the animation wizard, I've got the option explode it, so I'll go ahead and explode this item, or this assembly. Tells me how long do I want the duration. I'll say I want it to last for 3 seconds, and I want it to start. And then you can see that it creates the keyframes for me automatically. Now if I wanted to collapse it again, I can go back into the animation wizard, tell it to collapse, and then my duration would be 3 seconds, and then maybe I want it to start at 4 seconds. So what that'll do is append the collapse functionality towards the end of the assembly, or at the end of the animation rather. To select what study or what solver I want to use, I use the pull down menu on the left. For this particular animation, the animation based solver would be more than fine. So I can use calculate, you can see that it expands and collapses, which is what we'd expect. Now if I wanted to also go through and rotate the model, perhaps I can just rotate it around the x-axis. I can use the animation wizard for something simple. I want it to rotate it around once, and maybe I want it to last a total of 5 seconds, and I want it to start at 1 second. You can see that the camera keyframes are automatically added in. So using the animation wizard, you can create fairly quickly some simple animations. Now, if I wanted to do something a little bit more accurate, then I would want to use the basic motion solver. So in this case, I want to zoom in, and my animation is going to consist basically of this bar rotating, hitting the ball, and then sending it down the ramp. Should be fairly simple to do. So the first thing I need to determine is, well, I want this part to move. So I'm going to create a motor, select on the motor icon. I've got the option of a rotary motor or a linear motor. In this particular instance, I want a rotary motor. And I'll just go ahead and attach it to that circular edge, and you can see the direction of my rotation. I can change the type of motor that it is. In this particular instance, I'll use an oscillating motor. And maybe I want it to if I select on the icon, you can see displacement versus time. And go ahead and say OK. And let's see what you can see that my animation consists of within 5 seconds it rotating. But notice that there isn't any interference between the parts. The motion bar just moves, but it doesn't actually have any effect on the ball in the assembly. The reason for that is that there aren't any contact sets set up, so I need to tell the animation how the components interact with one another. So I can select on the contact set. Contact type are going to be solid bodies, and then I'm going to create contact sets between the 3 components. I don't really care about the bolt in this instance because it's not going to be functional in the animation. It's just there really for appearance, if nothing else. So I'm going to create contact sets between those 3 items and then say OK. Notice that my bar has a hatching over the top of it now. That's it telling me that there's a recalculation required for this particular animation. So I'll go ahead and say calculate. And so you can see that the ball was hit. It also bounced into the base, but it didn't go down the ramp. Let me zoom in just a little bit tighter. And also see that there's not any gravity on the ball. The ball just moves outwards. Part of the reason for that is, like I said, we haven't imposed any gravity on this assembly. It doesn't know what direction gravity is. Another reason is that within this assembly, or specifically on that component, there is a tangent mate in place. The tangent mate is between the ball and that top surface. So even if I apply gravity to this particular motion study, that tangent mate will result in that part not being pulled down by gravity because it's being told to remain tangent to that top face. So I'll need to turn that tangent mate off in order to get this to react appropriately. So before I make any changes, and this is kind of a general usage rule of thumb, is it's always good to take the time bar and slide it backwards. So you can slide forwards and backwards through time. I'll go ahead and suppress that mate at the beginning of the animation. And then I'll also go ahead and apply gravity to this. So I can select gravity. I can give it a direction reference. So I'll select this vertical edge, and then you can see that my gravity pointer is pointing down. Standard gravity value. And again, my animation is requiring an update. Let me move this out just a little bit so we can see. I also want a little bit more time in my animation, so you can adjust the keyframes, and you can adjust any keyframe for that matter by left clicking on it and dragging it. So I'll say this, I want this to be 10 seconds. So I'll go ahead and calculate again. And now you can see that the animation behaves a little bit more like we would expect it to. It also appears that 10 seconds is a little bit long, so maybe we'll come back and trim it back to 7 seconds. Calculate it again. So the nice thing about this is that just by applying motors and gravity and contact sets, you can see that within our assembly file or within our timeline, all of the motion has been handled for us automatically. So you've got a move function, explode function appearance, and you can change each one of those at any given keyframe. Right click, place key, and then you can adjust any aspect, whether it be move, explode, appearance, turning mates on and off, changing their values at a given points. You just select the point at select the key point at the appropriate time, and then change the value. But it's handled all of the because of the motion aspects using the basic motion solver. It's handled all of that information for us automatically. So suppose I wanted to create a little bit more of an informational study, maybe get the do some simulation data on that bar as it was contacting the ball in the study. If I come back, if I come back, notice that there isn't a motion analysis. So let me come back to the PowerPoint. The next thing we're going to talk about is a motion analysis studies. Before you turn the Addin on, let's kind of cover some basics about it. All the parts within a motion analysis are treated as infinitely rigid. So this means that there's not any internal deflection or deformation during the simulation. If you've got a top-level assembly with lots of mates, you're going to want to determine which need to remain rigid or which need to be remain flexible. The motion analysis is aware of that setting within a subassembly. To change that, you would right-click on the subassembly, go to its component properties, and then select whether the assembly or subassembly rather is rigid or flexible. If it's flexible, then any flexibility that it has on its own as a subassembly when it's opened on its own is going to be available in the top-level assembly. If it's rigid, then it views it as just a single item. Fixed components, items that have an F next to them so that they're purposely fixed in space, are fixed as or treated as fixed during a simulation. And then another consideration as you start moving into the motion analysis is how do you treat your mates? A lot of times people have a tendency to overdo mates or create redundant mates, and that's just for lack of really not having enough foresight to understand what you need to do with your mates in the context of motion analysis. But mates, as it relates to motion analysis, are there to remove degrees of freedom. The existing mates are automatically mapped to simulation, so that does make things easier, and it also does show you where it shows you how many redundancies that you have. Motors dictate displacement, velocity, or acceleration as a function of time within a motion study, and then, as always, gravity should be used when part weight is a factor for a simulation. If it's something that doesn't necessarily require that information, then you may not want to turn gravity on. But I think that if you wanted the most realistic results for a given Assemblies motion analysis, that maybe you should incorporate gravity just as a matter of course. So let's go ahead and take a look at turning the Addin on within SOLIDWORKS for motion. So go into Addins Motion, go ahead and say OK. So now you can see within my tool set up here, I have dampeners, forces, plots and results, and so on for this this particular type of study. I also have another pull-down menu item called Motion Analysis, and then you can see once that item is selected, more options become available. This particular study that I have already set up has the results plotted and the simulation already set up. Now, in order for the simulation buttons, over on the left side you've got simulation set up, create simulation or calculate simulation results. In order for that functionality to be added, you do need to have SOLIDWORKS simulation available and have the Addin turned on. So now with this particular animation, what I've done is set up, by selecting simulation setup, I've designated a particular time step for the simulation to go in and analyze the model. In this particular time step, 1.385 seconds, between 1.385 and 1.395 seconds is when the bar makes contact with the ball. So that's when I've told simulation to go through and analyze the results. So let's take a look at the results. Stop, and then I'll zoom in a little bit right before it makes contact. Might need to recalculate this. So it's nearly completed. Then I can go through and calculate the simulation results. And what that'll do is take the time step that I've set up. It's got a total of 2 time steps, and then it will go back after the motion analysis has been calculated, go back and analyze the contact and simulation results at that particular time frame. So now we should see not exactly sure why that's not working, but what we should be seeing is there we go. I think it was just moving too quick. You can see at point of contact, you have the simulation results, and then you can click by click see as it transitions over that the forces in the assembly as it makes contact. So granted, this is a very, very simplistic result, or a simplistic model. I think it's just I'm trying to show you what is possible without having a lot of overhead time and calculating during the presentation. So you can create an assembly or create an animation that does incorporate motion studies. The results also would show within the feature tree. You've got the ability to show, let me bring this in just a little bit better, velocity, and to set up those studies or set up the plots. You can select on results and plots. You can select a number of different categories: displacement, forces, momentum, energy, power, other quantities. So there's a lot of different options, and each one of these options, or the entire motion analysis aspect of SOLIDWORKS, could you could have a webcast in and of just for that topic. But in any event, it is possible, and you can also show deformation, factor of safety for a given simulation setup within motion studies. The next thing to show is the event-based motion studies, and this is new in SOLIDWORKS 2010. This basically helps you automate a lot of your simulation tasks, and it also makes dependent keyframes, or the dependent tasks, allows you to specify motion for a combination of sensors, previous events. So there's a lot of flexibility that you can set up and basically set up some rules for your motion study to function. So we go ahead and switch back over to SOLIDWORKS. I think it's easier to illustrate this just by showing the functionality. So this particular example assembly is basically you've got some pusher rods, which would be like cylinders, and then you've got a top-level assembly with a track in it. So to create this, with the simulation add-in turned on, you've got event-based motion view button over on the right side, so you can toggle back and forth between the list of tasks, which will create the different keyframes for you automatically, or you can look at the keyframes themselves. You can also left click and drag to split these so you can see the task pane, see the tasks and the keyframes automatically. So to add a task, I'll go and click on task, and there's a number of different settings. I can put in a description. I can make a particular trigger. Slide this back over just for a moment. I want my task to start at 1 second, and then within this assembly there are already linear motors defined, so I want to go ahead and turn on linear motor 5. If I move this over, you can see that this linear motor is attached to that shaft, and the linear motor basically is just going to be turned on and off. I can also change its value. So I'm going to say that needs to travel 200 millimeters. And then I can also change the profile. I'll make it cycloidal. Add another task. And in this instance, rather than making the trigger time, I'm going to make it based on another task. So this simplifies what happens with creating keyframes and sequencing things in your assembly. Since it's based on a particular task, if I ever change the value of task 1, then task 2 will update automatically. So it's creating a parametric relationship between the keyframes within the assembly, or within the animation rather than having to go through and kind of manually adjust them. If you've used animation before, or if you use it for a little while, you'll find that making adjustments to it can be a little bit of a challenge, because sometimes you can get just things out of whack. This methodology of using task-based, event-based motion analysis greatly simplifies any changes that are in your assembly, or if you need to go back through and make a change to the timing of a particular event. So I'm going to make task 2 dependent upon task 1. The condition is that when task 1 ends, task 2 should start, and then its trigger will be to turn on motor 6, and its value will be 200 millimeters for 1 second. Also make its value cycloidal. Task 3 will be dependent upon task 2. It will turn on motor 7. Task 4 will be dependent upon task 3. Which in turn turns on motor 8. So what we should see now, whenever we drag this over, is that there is a relationship, almost like a Gantt chart, of keyframes, so that you can see each task has its own relationship to the previous task. Switching back over to the timeline view, if we calculate this, can see that the keyframes were made automatically for us as well. As we mouse over each one of the keyframes, you can see that it's task 2, so it's related back to the event-based motion view. So this is good for setting up, PLC logic, those types of things, even for injection molds if you need to simulate the part ejecting and what might happen to it. And then again, you could use the output of this particular motion analysis could be used with a simulation, so that if you wanted to see the impact of a part as it was ejected from a mold, and then make sure that it cleared any standoffs within the mold and what happened whenever it hit whatever was going to receive the parts, what potential impact or deformation might happen to the parts. You can do all those things with motion studies in conjunction with simulation. So there's quite a bit of versatility with these utilities, especially in SOLIDWORKS 2010. So at the end of this, you could also go in, and there's a completed study. You can see that even task 1, extending and retracting each one of these actuators, you can get very complicated with the workflow of your event-based simulation. Again, the event-based simulation is new in SOLIDWORKS 2010. It's available in SOLIDWORKS Simulation Professional or better. And so that's going to be hopefully something that users are going to be embracing as they take a look at this new product. So hopefully this webcast has given you some indication of what's possible with SOLIDWORKS Motion, doing motion analyses, and some of the new things as far as event-based motion is concerned. If you have any questions on this, or if you would like to have questions answered, please email us at support@ddicad.com. Some of the other ways that you can get information is on our website. We've got tech tips. Obviously, you found this webcast archived at that location, and then you can also check out SOLIDWORKS Heard, which is Lou Gallo's podcast and website that features a lot of new information about CAD data and things that are going on in the SOLIDWORKS community. Thanks for watching.